In this lesson, we're going to talk about ions and the octet rule. To have a better understanding of what ion is, I need to introduce the octet rule first. So basically, elements with a full valence shell have a special stability. In the first 18 elements, a full valence shell, except for the first shell, contains 8 electrons. And atoms of noble gases each has 8 electrons in their valence shells. The exception is helium, which is stable with only 2 electrons in its valence shell. And atoms of other elements do not have a full valence shell. And atoms, when they combine with other atoms, tend to attain this electron arrangement. And there are 3 possible ways where an atom can achieve this stable arrangement. So it can either share, lose, or gain electrons. And when an atom loses or gains electrons, it forms an ion. So ion is basically an entity with a positive or negative charge. As I mentioned, atoms sometimes lose or gain electrons to form ions. And some elements, especially for metals, are more likely to lose electrons and become positive ions. And this is because metals tend to have less than 4 valence electrons, and therefore it is easier for them to lose their valence electrons. And this indicates that metals tend to have low ionization energy. And recall the concept of ionization energy from grade 10. Ionization energy refers to the amount of energy needed to remove a valence electron. And consider sodium in group 1. Each sodium atom has 1 valence electron in its outer orbit. And in order to achieve a more stable arrangement, a single sodium atom tends to lose that electron. And when it loses its electron, it becomes a positively charged ion. And a positively charged ion is known as a cation. Note that when we represent ion as per Rutherford diagrams, we enclose them with a square bracket and write this charge as a superscript outside of the bracket, as shown in this diagram. Here's another example. An aluminum atom has 3 valence electrons. Therefore, it will lose 3 valence electrons to become an aluminum ion with positive 3 charge. And now let's talk about naming those cations. So naming these cations is very simple. They have the same name as their element. For example, sodium ions are simply called sodium ions, and aluminum ions are simply called aluminum ions. For non-metallic elements, they generally have almost complete valence shells. As a result, non-metallic atoms tend to gain electrons in order to fill their valence shells. In doing so, they become negatively charged ions because electrons are negative. Consider chlorine as example. A chlorine atom gains 1 valence electron to fill its outermost shell, forming a chloride ion. And this ion has a charge of -1 because it has 17 positively charged protons and 18 negatively charged electrons. However, anions are named a little bit differently than cations. They are named by replacing the N of element's name with IDE name. The Cl -1 ion will be called a chloride ion, and the S -2 ion will be called a sulfide ion. In general, metals lose electrons to become cations, and nonmetals gain electrons to become anions. However, H, or hydrogen, is an exception. It can form either +1 or -1 charged ion, despite that it's a non-metallic element. The elements with multiple possible charges are called multivalent elements. Below is a table of some multivalent elements you need to memorize in grade 11. So, in the classical naming system, the suffix OUS refers to the ion with a lower charge, while the suffix IC refers to the ion with a higher charge. However, this naming system only applies to elements that have exactly 2 charges. And for elements with more than 2 possible charges, we can only use the IUPAC naming system, which uses Roman numerals in parentheses to indicate the ion's charge. And IUPAC stands for International Union of Pure and Applied Chemistry. And in this course, you need to memorize the Roman numerals from 1 to 10, like I listed here. By the way, as you may notice that In the classical naming system, scientists do not name those ions using their proper English name. Instead, they use the words that were borrowed from either Latin or French to name them. Let's briefly talk about the polyatomic ions. An ion that consists of more than one atom and with a charge is called a polyatomic ion. A polyatomic ion behaves just like an ion made of only one atom. And most polyatomic ions are composed of oxygen, nitrogen, phosphorus, sulfur, chlorine, and carbon. And here's a table that summarizes the polyatomic ions you need to memorize in grade 11. So please put them in your notebook and review them from time to time. About 99% of your body is made up of only 6 elements. In the order of abundance by mass, these elements are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. And you also contain much smaller quantities of sulfur, chlorine, sodium, magnesium, iodine, and iron in your body. The sodium ions, for example, play a critical role in the normal functioning of the human body. Sodium ions can help with your nerve impulse transmission, muscle contraction, and water balance. And you can get some sodium ions from sources like salt, cheese, and preservatives. And we'll come back to the table in the digestive lesson in my grade 11 biology series. And here's a summary for this section. You guys can pause the video and read it through. Lastly, I've got some questions for you. And that's about it. Thank you for watching, and I'll see you in the next episode.